So after dealing with the solutions of solving for the average atomic mass for numbers 1 and numbers 1 and 2, and you've seen the answers, the step-by-step process here for number 1, and number 2, it's the same process, but we're making it in a shortcut way so that it will be faster and easier for you to solve. So you can have this version as well. You will arrive at the same answer, and all the 3 steps are also there. So now it's time for us to go to the concepts for the other items in this exercise. So let's proceed to number 3 here. And let's read this all together. Number 3, would you mind changing this word to a word 3? It's not 4 isotopes, but 3 isotopes. Okay? So let me read it with you. 3 isotopes of lead include lead 204, then second is lead 207, and third is lead 208. 3 isotopes. The second sentence says, the average atomic mass of a lead atom, so average atomic mass of a lead atom is this one, 207.2 AMU. Okay? Which isotope is likely to be the most abundant? So let's dissect the statement and put our given on paper. So 3 isotopes. We have lead. I will use now the symbol of lead, which is Pb. So lead is Pb and dash 204. The second isotope is lead 207, so Pb 207. And the third one is lead 208, so Pb dash 208. So these are the 3 isotopes of hydrogen. Then the question is saying, I will choose which of the 3 is the most abundant. How do I know? If you look at the other given, the average atomic mass of 207.2, this is what we will use to find out the answer. So let me put it here. The average atomic mass is equal to 207.2 AMU. So I'm just copying that. So how do I relate this value to the values here? Because they're all numbers. So this is the relationship. If you're looking for the most abundant isotope, the most abundant isotope has the mass that's very close or near to the average atomic mass. Let me repeat. The most abundant isotope is the isotope that has a mass number that is very close to the average atomic mass. So our average atomic mass is 207.2. Then you look at the mass numbers here. Which among the 3 is very close to 207.2? Is it 204, 207, or 208? Obviously, it's going to be the 207. 207.2 is very close to 207. Therefore, so therefore is the 3 dots. Okay, that's the symbol for therefore. Therefore, the most abundant isotope is Pb 207. And you will say there in your reasoning that because 207 is very close to 207.2. And that's how you get the most abundant isotope. If we reverse the thinking, how about the least abundant instead of most abundant? If it's least abundant, so you reverse your thinking. Whichever is the number that's very far.
Maybe 204 then.
Okay, so it's going to be 204 then. The number that's very far from the average atomic mass is the least abundant. And that's how you answer questions related to number 4. Question to number 4 is, what do all isotopes of an element have in common? So let me give you examples of isotopes, okay, and tell me what they're common. I will give you the 3 isotopes of hydrogen. So you have hydrogen 1 and 1. So this is hydrogen 1. The second isotope of hydrogen is still a 1 there, of course. And the 2 on top, that's hydrogen 2. And then the third isotope of hydrogen is, of course, atomic number of 1, but the mass number is 3. So tell me what's common among all the 3 isotopes.
All 3 have H, and all 3 of them have the same atomic.
Correct. So we begin with same symbol. So therefore, same symbol meaning the same element, of course. And Anthony, thank you for your answer. And because it's the same element, therefore the atomic number below, it's also the same. Same atomic number. And which among the 3 subatomic particles is equal to the atomic number? Is it the protons, electrons, or the neutrons? If the atomic number is the same, so which subatomic particle is it equivalent to? The number of protons. So it's the positive. That's the same with atomic number. So same number of protons. Same element, same atomic number, same number of protons. It follows. That's always with isotopes. Same element, same atomic number, same protons. And that gives us number 5. Explain why carbon-14 and nitrogen-14 are not considered isotopes. What is the answer? Why is it that we don't consider carbon-14 and nitrogen-14? So we cannot consider these 2 as isotopes because they're not the same element. Carbon is carbon, nitrogen is nitrogen. Not the same element. So they're not isotopes. Now we'll go to number 6. This is the very last. We are asked to write the atomic symbol for the 2 isotopes of uranium whose atomic number, let me move, whose atomic number is 92. And then it says here that one isotope has 142 neutrons and the other isotope has 146 neutrons. That's kind of a lot, Miss Narca. So let's break this down. Whatever is in our given, let's put it in writing. Let's first start with the first element mentioned. It's uranium. 1 element. So uranium. So the element's name is uranium and the symbol is U. It says there. And it has 2 isotopes. Okay? 2 isotopes. That means we'll have 2 symbols for that because there are 2 isotopes. Then it says atomic number is 92. So let's put it down. Atomic number, or the symbol for that is the Z, is equal to 92. Then 1 isotope. So 1 isotope has 142 neutrons. So let's write that down. 142 and 0 neutrons. The second isotope has 146 neutrons. 146 neutrons. So how do we write the symbol? Let's recall the format. What's the format of the symbol? The format is like this. If you recall in the previous lesson, that's X, A on top, and then Z below. X represents the symbol of the element. Z represents your atomic number. And A represents your mass number. And mass number is equal to protons plus neutrons. So let's write that down. Let's write the symbol first. Symbol is U. So I'm going to write letter U and letter U twice because it's two isotopes. Then I put the Z. The Z is 92. So I put 92 here and 92. Then all I need to do is solve for my mass number for the top. It's protons plus neutrons. So how do I do that? My protons is just the 92. So I'll add it to the 142. 142 plus 92, that's going to be 234. And for this one, 146 plus 92, that's 238. So all I need to do is put 234 here, and this is 238 right there. And so, these two are my final answer to the symbols being